Section 3.1 continued. This is video number 2. We're going to talk about domain, and we're also going to talk about the greatest integer function. For domain convention, unless information to the contrary is given, the domain of a function of f consists of every real input for which the function rule produces a real number output. The domain of a polynomial function, such as f of x equals negative 3x cubed minus x squared plus 7, is the set of all real numbers since f of x is defined for every real value of x. Now remember, polynomial functions, you don't have any radicals in your equation, you don't have variables in the denominator, so that's just from Algebra 2, so that's why we can say it's all real numbers. However, in cases where applying the rule to a function leads to one of the following, the domain may not consist of all real numbers. It's still possible that it can, but you have to check, which is what we're going to learn how to do. So you have to be careful, division by 0, and also the square root of a non-negative number. So remember, or you can say the nth root where n is even. So any roots that you have that are even, you have to watch out for negatives underneath the radical. Now, when I'm doing these problems, there's two questions that I always ask myself. I say to myself, do I have any variables in the denominator? And why would I say that? Because remember, we can't divide by 0. And then the second one is, do you have any variables underneath an even root? And why is that? Because we can't have negative underneath an even root. So if you have those two things, that's when you don't have all real numbers for your domain, and you have to do what we're going to do with these next steps. Now, of course, we're going to be doing this without our calculator. For right now, I'm going to show you on some of them how to check using your calculator, but however, on your next quiz and test, you'll have to be able to do this without. So looking at this function, I asked myself the two questions. Do I have any variables in the denominator? No. Do I have any variables under an even root? I also do not, and I know this is a polynomial function, therefore the domain of this is going to be all real numbers. So remember, when you're writing that, we're going to use interval notation, so negative infinity to infinity. So this is the domain, and I'm going to write D stands for domain. If I were to go ahead and look at the graph of this, I can also confirm. Notice if I plug it into my y equals, I already have it there, and I hit graph. I know this is going to be a quadratic graph. And for this function, I can plug any value I want into x and get a real number answer output. For b, however, notice that I asked myself the two questions. Do I have any variables in the denominator? No. Do I have any variables underneath an even root? Yes, I do. Remember, what you have there cannot be negative. So what I like to do is I take what's underneath the radical, u plus 4, and I'm going to set it equal to 0, because can you take the square root of 0? Yes, remember the square root of 0 is equal to 0, and that's okay. So if I do this, I get u plus 4 equals 0, so u is equal to negative 4. Now, the way that I like to find the domain is it helps me to make a number line here. So I have this number line, and on my number line, I am concerned with the value of 4, because if 4 makes this radical 0, then I have to figure out what's going to make this underneath this radical negative. So on my number line, I'm just going to put the test value that I have, which is negative 4. Can I be equal to negative 4? Yes, because we can take the square root of 0, because if I plug negative 4 in here, I would get the square root of negative 4 plus 4, which equals the square root of 0, which is just 0, and that's okay to have. So that's why I have a closed circle. Now I have to figure out, testing each side of the number 4 to figure out where numbers are not going to work. So if I do, let's say, numbers to the right of 4, so I'm going to test maybe, let's say, 0, because it's easier. So if I test 0 and plug it in here, so I'm going to test 0. When I plug it in, I get the square root of 0 plus 4, which is the square root of 4, which is equal to 2. Did that give me a negative underneath my radical? No. So that means that numbers on this side of my number line are okay. So let's check the other side. If I test the number, so what's less than negative 4? Let's just do negative 5. So I'm going to test negative 5. So if I plug that in, I would get negative 5 plus 4, which is negative 1. And again, we can't have this. So these numbers over here are not going to work. So when I'm doing my number line, means I'm going to shade my number line to the right. And that's going to help me find my domain now. So I'm going to go ahead and erase this so I can have room to write. So that means that starting at 4, including negative 4, sorry, not 4, but negative 4, I have from negative 4 to infinity, this is the domain of this function. And if you recall from Algebra 2, well, we're just graphing a radical function. If I go to my graphing calculator and my y equals, and if I plug this in, I'm just going to clear that one out. If I plug it in, so I'm going to hit enter and the equals to graph this and hit zoom 6. Here's my graph. Notice you can also confirm that what happened to my graph. It moved to the left 4, and notice that it's starting right here. So this is -4. We have all x values to the right of -4, and we don't have anything to the left because anything to the left of -4 as an x value would make underneath your radical negative, so that we can't include it with our domain. So it's easy to check some of these. So this would be my domain. For anything with a radical, you could also just take what's underneath a radical, u plus 4, and set it greater than or equal to 0, because remember it has to be greater than or equal to 0. If I would have done that, I would get u is greater than or equal to -4. Which is what is on my number line. The reason I don't write it that way is only because in the past that has confused students. If you prefer to use a greater than or equal to and solve it, and then use that to help your answer, that's fine. However, I'm just going to use equals or not equals in my case. So let's go to the next one. Now for C, again, I asked myself the two questions. Do I have any variables in the denominator? No, I do not. Do I have any variables underneath an even root? Yes, I do. So I take what's underneath the even root, which is x squared minus 36, set it equal to 0. Why can it equal 0? Because if I plug my numbers in, which we'll do in a second. So first, let's go ahead and solve this. So in order to solve this, I can do x squared is equal to 36, and then take the square root. Don't forget your plus or minus. So x is equal to 6, or x is equal to -6. And if I plug 6 or -6 in here, I would get 6 squared, which is 36. 36 minus 36 is 0, and the square root is 0, 0. And since it's not in my denominator, that's okay. So on my number line, I'm going to put -6 and 6. Because I can have 0, I'm going to make closed circles. Now I need to test on each side and in between of each of these numbers. So the first part where I'm going to test is I'm going to be over to the left of -6. So I'm going to test, and you can test any numbers that you want. It doesn't really matter what you pick as long as it's to the left. So let's this time test -10 and plug it into my equation. So when I plug -10 into this equation here, I would get -10 squared. So -10 squared would become positive 100, and 100 minus 36 does not give me a negative number, so these numbers are all going to be okay. So I can use those. The next number that I'm going to test, in between -6 and 6, the easiest number would be 0, so I'm going to test 0. So if I plug 0 in here, I get the square root of 0, or 0 squared is 0, minus 36 would be the square root of -36. Because I have a negative underneath there, that means any number in between 6 and -6 will not work. All of those numbers in between are going to make underneath my radical a negative. So now let's test to the right of 6. So I'm going to use 10 again because 10's easy. 10 squared is 100. 100 minus 36 is not going to give me a negative number. Therefore, these numbers will work. And even if I test like another number like 7, 7 squared is 49. 49 minus 36 is also not negative. Even if I did 6.1, you would see that you wouldn't get negative numbers. So for this, that means that on my number line, I have numbers going this way, and I have numbers going this way, so that's going to help me write my domain. So just like we did before, we have parenthesis -infinity, because you always go in order of your number line, least to greatest. So -infinity to -6, we're including -6, union, bracket, 6 to infinity. So this would be the domain of this equation. Now if I go ahead and take a look at my calculator, so I already have this plugged into my y equals. And remember, you're not going to have your calculator on your test. However, for your homework, you can go ahead and use it because it can help you check your answers. So if I hit graph, notice this is what my graph looks like. So we have nothing in between 6 and -6, but I know it doesn't look like it starts here. Your graph starts here and goes this way and this way. So we have values above 6, or values below -6, including both 6 and -6. Now for the next one, Again, ask yourself the two questions. Do you have any variables in the denominator? No. Do you have any variables underneath an even root? Yes. So that means we have to be careful and check our domain. So for this, I take what's underneath of here, which is u squared plus 4, set it equal to 0 because I can have 0 in my numerator. Now when I solve, I would get u squared is equal to negative 4. And notice I take the square root of both sides, so u is equal to plus or minus the square root of negative 4. But uh-oh, I can't do that right there because we can't have a negative underneath the radical. So what does that mean when something like that happens? Which doesn't normally happen, but in some cases it will. Now that means that no matter what we plug in for u, we are never going to be able to get negative underneath our radical. Well, why would that be? Notice that anything that you have, you're squaring your numbers. So if you plug in a positive number, you're squaring it and then adding 4. If you plug in a 0, you're squaring it and adding 4. If you plug in a negative number, you're squaring it and adding 4. So no matter what you do, you can never get a negative for this one. And because we can never get a negative underneath the radical for this one, that means that any number on my number line is going to work. So the domain is going to be all real numbers. Now, like I said, I picked this problem on purpose just to show you that just because there's a radical in my equation doesn't mean I'm going to have any domain restrictions, such as in the case of this problem right here. However, you always want to check to make sure. So when I was solving it, because as I solved it, I got a negative underneath the radical, which I can't have, I know that anything for x will work. So if I go to my graph here, I'm going to go to my y equals, and let's go ahead and I'm going to clear that one out and go to the next one and hit graph. And when I graph this, here's what my graph looks like. And if you go to the table, you'll also notice that anything you plug in for x will work. So any numbers work. And I forgot I put my table on auto. So if I go here and change this back to, change it back to auto, I can see that anything that I plug in will work. So let's keep on going. Let's do some harder ones. For this next one, now, again, ask yourself those two questions. Do I have any variables in my denominator? Yes. Do I have any variables underneath a radical? No. So now I'm only concerned with things that could make variables that can make my denominator 0. So how do I solve these problems? Well, the way that you solve these problems is you take what is in your denominator and you set it not equal to 0. So in this case, x minus 1 cannot equal 0. Because I can't divide by 0. So x cannot be equal to, in this case, 1. So on my number line, I'm going to put 1. Now, for these problems, you can simplify that if you wanted to, but it's not necessary. So at 1, now I have an open circle because I can't have 0 in my denominator. So that's why that's open instead of the other ones where you can have 0 underneath a radical as long as it's not in your denominator. Now I need to do my test point on either side of 1. So let's do to the left of 1, which is 0, and that's easy to do. So I'm going to plug 0 into my equation, and I don't have to plug it into the numerator. Really, I only need to plug it into the denominator to make sure it doesn't equal 0. If you want to plug it into the whole equation, you can. So in this case, I'm just going to plug 0 in here. So if I do 0 minus 1, I get negative 1. Are you allowed to have negative 1 in your denominator? Yes, as long as it's not 0. So let's just go ahead and do this whole thing. So I have 0 squared minus 6 times 0 over 0 minus 1. So 0 squared is 0. Minus 6 would just be negative 6. And that's 6 times 0, so it would be 0 over negative 1. 0 in my numerator is okay. I'm allowed to have negative 1 in my numerator. That's okay. Just can't be 0, so this is just equal to 0. So therefore, I know that any number I pick to the left of 1 is going to work, so this is okay. Now let's pick to the right. So if I pick 2, and I plug 2 into this equation, in my denominator, 2 minus 1 would just be 1, and then I would have something in my numerator, so any number over here is also going to work. So if you look at this, everything on your line works except for 1. So in that case, how do I write this? Domain would be from negative infinity to 1 parenthesis, because we're not including 1, union 1 to infinity. And if you recall from Algebra 2, this is actually a rational function that we're graphing. So remember that in Algebra 2, what we did was we had to look for holes and vertical asymptotes, etc. in my graph. So if I go to my graphing calculator and look at this one, and hit graph. Notice that this is what my graph looks like, and you can see that you actually have, if you remember from Algebra 2, there's a vertical asymptote right there, so any other x value will work except for an x value of 1, and even if you go to your table, you see error at 1 because, again, there's that vertical asymptote there, which we're going to be talking about rational functions again in the next chapter. So if you don't remember that, that's okay. We will get there again, but that's why we have all real numbers except for 1, and since we're in pre-calculus, we want to write that using interval notation. Now for the next one, it's kind of the same problem except for we flipped it. So for this problem, you do the same thing. There's no variables underneath a radical, but we do have variables in the denominator that we have to be concerned with. So I take what's in my denominator, which is x squared minus 6x cannot be equal to 0 because we can't have 0 in my denominator. Factor out the x to solve this, or you could use a quadratic formula. Factoring in this case would take you a lot less time. So remember, when you have two things like this, you have to set each not equal to 0. So x cannot be equal to 0, and x minus 6 cannot be equal to 0. So when I solve the second one, I get x cannot be equal to, so x cannot be equal to 6 in this case. So x can't be 0 and x can't be 6. When I go ahead and put that on my number line, I would have 0 and I also have 6. They're open circles because if I plug 0 into this equation, I would get in my denominator 0 squared minus 6 times 0, which is 0, and I can't have 0 in my denominator. And I'm just to show you again, so if I did that, I get 0 squared minus 6 times 0, which is equal to negative 1 over 0, which we can't have. So that's why we have to have an open circle, and the same thing would happen with 6. Now I need to test my number line on either side of my test points that I have here. So on the left, 0 would be negative 1. I'm just going to test the denominator. So in my denominator, if I plug in negative 1, I would get negative 1 squared minus 6 times negative 1. So this is 1 minus becomes plus 6. So I would get 7, which is not 0. Because it's not 0, that works. It's okay. If I test in between 0 and 6, let's do 1. So if I do 1 squared minus 6 times 1, I would get 1 minus 6, which is negative 5. Because we don't have any even roots, we're not worried about the negative, so these numbers work. If I test to the right of 6, like 7, and plug it in, that also does not make my denominator 0, so those numbers work. So basically, for this one, everything works except for 6 and 0, so my domain would be negative infinity to 0, parenthesis, union, parenthesis, 0 to 6, parenthesis, union, parenthesis, 6 to infinity. So basically, again, that says all real numbers except for 0 and 6, but we always want to write it in interval notation. Now let's look at the next one. No variables in my denominator this time. However, I do have variables underneath an even root, so I have to take that. And since it's not in my denominator, I can go ahead and set it equal to 0. How do I solve this? I can use a quadratic formula. That's going to take you a lot longer than just factoring in this case. So I'm going to factor this. So I have x minus 3, actually plus 3x minus 2, because 3 times negative 2 gives me negative 6, and then that would give me a middle term of positive 1 when I solve it. Set each of your binomials equal to 0. When I solve, I get x is equal to negative 3 and x is equal to 2. Those are the two numbers I'm putting on my number line. So negative 3 and 2. This time I can use a closed circle because, again, it's not in my denominator, so we can have 0 underneath the radical. That's okay. So when I do my test values for this one, I'm test again on to the left and right of each number and in between. So let's do negative 4. And again, I'm looking to see if it's going to make anything underneath my radical negative. So if I do negative 4 here, I would get the square root of negative 4 squared plus negative 4 minus 6. So 4 squared, of course, is 16. And then negative 4 and negative 6 is negative 10. So I end up with a square root of 6, which is not negative. That means that the values here are going to work, so those are okay. Let's test in between negative 3 and 2, so an easy number would be 0. So if I test 0, I would get 0 squared plus 0 minus 6, which gives me the square root of negative 6, which we can't have, so these numbers will not work. And again, you don't have to use 0. You could have used 1. You could have also used 1.5. It's just an easy number to use. And to the right of 2, we could use 3, or we could use 4, 5. Like I said, it doesn't really matter. I'm going to use 10 in this case. So 10 squared is 100, plus 10 minus 6 will not give me a negative number. So these numbers are also going to work. So for this problem, I have numbers this way and this way, but not in between. So my domain would be negative infinity to negative 3 union, and I should do bracket here, sorry. Union bracket 2 to infinity parenthesis. And again, you could also use your calculator to kind of help you see that that's what it would be. For the next one that we have, in this case, we're going to look at this problem and notice that not only do you have variables in your denominator, but you also have a variable underneath an even root. So in this case, we take what's in our denominator, root x plus 1, so we take what's underneath that radical, x plus 1. Now it cannot be equal to 0 because then it would be 0 in my denominator. So now I take that and set it not equal to 0. And again, the reason is because in this case, when I saw this, I get x plus 1, or x is not equal to, in this case, negative 1, when I solve for x. And if I put negative 1 in my equation, I would get negative 1 over the square root of negative 1 plus 1, which would give me 1 over the square root of 0. And remember, I can't have 0 in my denominator, so that is why it's not equal to in this case, whereas the other ones where the radical was not in the denominator, it was equal to. So now we have negative 1 that we're testing. It's an open circle, so now we need to figure out which numbers are going to work, to the right or to the left or both, possibly. So if I pick a number that is below negative 1, so negative 2, if I plug that into my equation, so I could do negative 2 over root negative 2 plus 1. I get negative 2 over the square root of negative 1, which I can't have the square root of negative 1, so these numbers are not going to work down here. I didn't really need to plug it into the whole equation. I could just use the denominator and seeing that it made my underneath my radical negative, but if you want to do the whole equation, that's fine. So then let's do to the right of negative 1, so 0 is real easy. So 0 over the square root of 0 plus 1, which would give me 0 over the square root of 1, which is 1. 0 in the numerator is okay, so these numbers will work, so anything on this side will work, and again, you can pick another number if you want to test it, like 10. So then if you did 10, you would get this, which would be 10 over the square root of 11, and that's okay again. So you don't have to pick 0 to use. So in this case, my domain would be parenthesis negative 1 to infinity parenthesis. Now, as you get really good at this, you won't need to make these number lines. I just like to make them for right now since we are learning how to do it. It helps me. And of course, as a second resort, when you're doing your homework, you can always use your graphing calculator to check. However, you will not have your graphing calculator in the next quiz that we have. We'll go ahead and get to the last part, which is the greatest integer function, and we'll talk about that in the next video that we have.